So the question is as follows. So you're given two strings, S1 and S2, and you should return true if S2 contains a permutation of S1 or false otherwise. So let's look at this example here. So we have S2, which is this long string here, and S1, which is this string. So we need to determine whether string S1 is a permutation of it can be found within S2, right? So before that, let's understand what permutations are, right? So let's say you have a string A, B, C, right? So what a permutation would mean is like all the different combinations of unique strings which contain the exact same letters in the exact same frequency. So let's say if ABC, right, then we can also have ACB, we can have BCA, BAC, CAB, and CBA, right? So we have 6 possible permutations. So let's say if our string was ABC, we will need to find whether any of these 6 are going to be within the string that you're looking for, right? So let's look at the example that we have in this question, which is AB, right? So notice that AB has 2 permutations, which is AB and BA. And notice that there is a BA in this string, so we can return true in this example. The other example 2 here says that there is an O here, and yeah, just like this. So what we can see here, that now there is a gap here, and that now this string does not contain either AB or BA, right? Like even though we see that there's a B and there's an A here, if it's not a proper substring, right? And also there's like a gap here, so length of this is 3, and what you're looking for is either AB or BA. So we can kind of tell from this that at the end of the day, the length of the substring that is going to be in S2, that is a permutation of S1, is going to have the exact same length of S1, right? We know that all permutations of S1 are going to have the same length, right? It's AB, BA. Even in the case of ABC, it's always going to be of size 3, right? So what can we know from this, right? We know that the length of the substring will be length of S1. So pretty much what we need to do is just check in S2 whether there is a string of length SS which contains the same characters as S1. Another thing, so we can pretty much just go through from each round, right? So we can start off, let's say if the length is 2, right? We have AB and BA, right? So it means the length is 2, right? Length is 2, right? So we just need to check whether EI, ID, DB, BO, OA, AO, and OO are valid permutations. If they are, then that is going to be true, right? If it's not, then it's not going to be true. Like example here is, let's say we go back to example 1, and we have an O here, right? You realize that we go the same order, so EI, DB, and then we see BA, which is a valid permutation. So in that case, you can return true, as we have found a valid match for permutations, right? So the question is, so now we figure out that we can kind of like slide through the string S2, then check whether every substring of length 2 is going to be a permutation. But how do we do that, right? Like that's the bigger question. So if you look at something, we can know that we can use a hash map for this. So if something were to be a valid permutation of something else, we will know that the frequency of elements will be the same, right? So what do I mean by this? So we know that AB is a valid permutation of BA, right? So what does this mean? So let's say we have a hash map which has a frequency count of each element, right? We know that for both these strings, the length for both these strings, we have A with a count of 1 and B with a count of 1, right? Let's say in the example that we have another string of, let's say, ABA, and then we look at all the different variations, right? this is some of the examples that we can use, right? In both of these permutations that we have drawn out here, we can another option is like a b, right, or something like that. So we can kind of figure out that in all the value permutations, we know that the count of a has to be 2, right, and the count of b has to be 1, right? So from this, we'll know that if a string is a valid permutation, it would have the exact same frequency map as S1, right? So that is the key to solving this problem. And moreover, you notice that to do the sliding window operation, as we can see through the code data, we will need to find an efficient way to update the hash map, right? So let's look at the first string here, right? So we notice that let's say we have a sliding window operation, right? So we have EI, none of them match AB or contain any characters from AB. So the hash map is going, let me draw something here. So this is going to be the hash map, right? So it's initially going to be empty, right? Of course, we realize that this is the first substring, right? So we'll know that there is no match between EI and AB, so the hash map can be initialized, can be set as nothing, right? And then we move to the next one, which is going to be ID. Is also going to be nothing, right? Because I and D don't match with A and B. And then we go to DB, right? And then now when you're here, you notice that the count of B now becomes 1, right? There is 1B present, right? And then when we go here, you notice that now you see an A, right? And A is 1. This matches the initial frequency count of S1, which is also B1A1, so we can return true as a valid match has been found. So did you notice something when I did this operation? So let me go back in time to when we were at this point, right? We were at DB, right? So we were at this point, and you kind of notice that the frequency map was 0, right? Now when we it was B1, right? Now we know that we need to slide over to this new point, which is going to be BA, because we're moving one step to the right, right? We need to check every single starting point for length of S1, which is 2, right? So we were at DB and then we went to BA. Notice that B does not change, right? The frequency of B is going to be the same, right? But you notice that since you're moving one from here to the right, you'll notice that the frequency of D, if it was present, would have dropped, right? And the frequency of this would have increased by 1. So this one would, the frequency of A would come up by 1, and the frequency of D, if D was valid in the S1 string, would have dropped by 1. So this gives us a efficient way to update the hash map as we go from one sliding window to the next, right? All we need to do is to decrement the count of the leftmost element, and then also like increment the frequency count on the rightmost element, right? So when we are at BA, you'll kind of realize that yeah, we get a count of A1, right? So and then we can return that they are true. So now that we have understood the intuition of how to solve the problem, let's look at the code and how we can solve it, right? So here is the code, right? So so we have a first base case. So let's say if the length of S1, which is what you're looking for, is greater than the length of S2, which means that it's not possible for there to be a permutation, right? So in that case, we can return false, right? Otherwise, we can proceed on with our operation. So we initialize a hash map, right? So this HM hash map will contain the frequency counts of all the elements in S1, which is the permutation we're looking for. Notice that we are doing something different here. So in this case, we are incrementing the values, but to solve this problem, I'll do a way where we decrement the values instead, right? So I'll explain that later in the code. So we have a hash map which will contain the frequency of the characters in S1. So yeah, so this for loop kind of sets up the hash map, right? So we iterate through the string S1, and then if the character is not in hash map I equals 1, otherwise we increment the counter, right? This is to take care of cases where we get repeats of the same character, right? Let's say it was ABA, right? And we need A to have a count of 2. Moreover, previously I mentioned that we have to go through each sub window, each potential permutation, and then check whether the frequency is what we need, right? So what do we do here? We set up a check hash map, right? So this check hash map is going to allow us to compare whether our current hash map is the same as the hash map that we need, right? So what do we do here, right? We set it up initially as an empty dictionary, and then for every element that we found in the hash map of the permutation string, we set it to be 0. I'll explain why we set it to 0 in the future as we go down in the code, right? So first, so this is how we set up our sliding window operation, right? So as we can see here, the starting point of the sliding window is going to be index 0, right? Which is going to be here, right? Which is going to be here. And then the end point of the window is going to be the maximum possible length of the permutation, so it's going to be ei. Like let's say if I had an example where I had a string A, B, C or something like that. Okay, let me draw this out here. Let's say if my permutation I'm looking for is like A, B, C or whatever, right? So let's say this is S2, and then we need to look for A, B, C. So we notice that the first sub window is going to be ABS, right? Because that's the length of ABC, and we will know that the length of the candidate substring is going to be the same length as the permutation of the length of S1, right? And then after that, the second second one is going to be BSD, right? So this is after like the first window has been completed, right? And then we go on to SDK, right? So we go on and on until we reach the end of the of string S2. Okay, so now that we know that, we will know where to set the right pointer, which is going to be ln-1, right? Which is going to be the rightmost point in S2, where the first possible candidate string ends. And we also set a init dictionary, which is going to be a deep copy of HM, which is what we set up here, right? And this is what we do for the first like to initialize the hash map, initialize the init hash map, right? So previously, remember that I said that we set check I equals to 0. The reason why we're doing here can be explained here, right? So what we do is to iterate through S1, right? Which in this case is AB, right? Which is yeah. So for every index in I, we check whether S2I is in init, right? If it is, then init S2I minus equals to 1. So what this would mean, like, so let's say if our first substring, okay, let's say we have a let's say our target permutation is like AB, right? And then we have a string BA whatever, right? So if you notice that we compare, right? So if for I in range then S1, which is AB, if S2I is in init, then init S2I minus equal to 1. So let's see what init is going to be, right? So hashtag so init is going to be a1 and b1, right? So we notice that when we have this, then let's say s2I is an init, right? So s2I, s20 is going to be b, right? So b becomes 0, right? And the second iteration of this for loop, we will have s2I, which is going to be a, and then we init s2I minus equal to 1, which is going to be 0 as well. If you notice that this is going to be the same as check, right? Like check is it's also going to be this exact same dictionary, right? So we can return that is going to be true. So let's look at our main while loop as we solve this problem, right? So the condition of this while loop is just to make sure that we don't exceed the bounds of string s2, which is what we're looking for, right? And if we don't find a match, then we just return false in the end of this problem, right? So as we have done here for the first possible candidate, for every possible candidate, if init is equal to check, right, we can return true. All right, this is the case where we see a, b, and b, a, right? But let's see an example where we have this, right? The string starts off with a, j, o, e, whatever, right? And then so in this case, you notice that init will not be equal to check, right? And of course we know that b is still going to be 1 here, but then if you look at check, right, check requires that a equals 0 and b equals 0. This kind of makes sense because we do not see a b in aj, right? So in that case, if we do not see it, then we go on to this logic, which is the case that if s2l is an init, we kind of increase the count, right? So this is what I meant when we went from db to ba, right? So if d was in the initial hash map, we decrement the count by 1, and then we go to the right, and then we increment by 1. So this line in the code is to decrement the d count, right? And then we increment both the left and right pointers by 1, right? And then we also have a check for our left and right because we're increasing them by 1, right? You check whether they are like out of bounds. If they are, then we can break out of this while loop, right? And then now we check if s2r, right, which is the new right pointer, is an init, and then init s2r minus equal to 1. So what this means is let's say we now go, so we know that db is not going to be a valid match, so now we are at ba. So at this point we will know that the count of b will be 0 and a will still have been 1, right? So there was no d to decrement, so it doesn't matter. So we have ba, right? So ba, a is now going to be 1 minus 1, right? It is going to be 0, right? So check will be the same as the init, and then we can return that is going to be true. So so the opposite of counting frequency, right? So the difference here is that we increment the count of d, and then we decrement the count of a, as we now need to check whether the frequency counts are all 0, right? Okay, so that's what we do here, right? So when this happens, then the init will be changed, and then we check if init equal to check, and then we return true if a valid permutation has been found, right? If a valid match has been seen. So that's pretty much the entire code for this question. So let's look at the time complexity of this problem, right? Leetcode says the time complexity of this solution is going to be O n time, right? But of course we only go through the loop once, and we increment left and right pointers, right? Every single time we go through it, right? But notice that init equals to check is going to be an operation which takes O of n time if both dictionaries have same length, right? Because you need to compare the frequency count of every key in the dictionary, right? So if it's going to be the same, it's going to take O(n) time, right? But otherwise, let's say if the values of the size of dictionaries is different, like in it's different size from check, then we notice that it's going to be an O(1) operation as time if both dicts have different length. Cause we can just compare the length of dictionary and then just return whatever this could be, right? So there's some variability in the time complexity of this if statement, right? So in the worst case, it is possible that it could run up to O(n) square time complexity, right? Let's say the dictionaries have all, if init and check have the same length. Ultimately, we will realize we need to run O(n), which is the main while loop, and then this one also take O(n) time, so it will end up taking O(n) square time. But I guess many cases didn't really have the scenario, so that's why we ended up with an overall time complexity of O(n). I noticed that it's also likely that there'll be a mix of dictionaries with the same length and different length. So that's why there could be some averaging involved also, which brought down our time complexity from O(n) square in this example. Right, so let's look at the space complexity. Space wise, the hash map is going to be of OS1, and then yeah, so it's also going to be of a linear space complexity, right? So that is how you solve the problem of today's Leetcode challenge. So thanks for watching, and have a great day ahead.